I want to know if there are any Canadians in the house.
We got one.
You got to make some noise. I was in Vancouver, and I know you guys make noise. I have to show you this picture. This was my experience. I got to go to, this is an amazing experience for me, but I have a friend that lives in Vancouver, and I got to go stay at his house and experience the Olympics as a spectator. And I didn't have to work. There were plenty of other folks from my company, and about, I think there were 14 different teams that worked on the digital Olympics broadcast. But I had so much confidence in my team that I got to go and spend time in Vancouver. And see if I got one more shot. Of course, there's, I don't know if you guys know .NET Rocks. Anybody knows that podcast? That's Richard Campbell from .NET Rocks with our tickets. And I want to show you, I just got like 3 pictures. There's the hockey game we went to. No, we really did go to a hockey game. That's me and my son we saw the U.S. men's team play. There's no Norwegians in the house, are they? Because I would have already heard some hollers. This is the Norwegian men's curling pants. Exactly. This is the pants of the Norwegian men's, the Norwegian men wore, which I thought were awesome. No, not mine, but you could buy them. Sochi is the city on the Black Sea in Russia. They had a huge pavilion showing off the Winter Olympics 4 years from now. So this is the branding experience you're going to see in 4 years. This is a curling arena, which was amazing. First of all, curling is awesome. I learned what curling was when I was there. But what was really interesting is the location for the curling arena. I mean, it's a big Olympic production, and it's across the street from somebody's house. It's just in some little residential neighborhood. And this dude not only was at the hockey game, but he was also at the curling match. The Abraham Lincoln guy. At both the curling game and the hockey game, they put him on like the big jumbo cam, and he got a huge round of applause. But there's the curling rink, and we were fortunate to see the women's team. And all I can say is curling is very nice. 3 hours of watching this sport. It was very good. Anyway, that's good. And by the way, there's probably 100,000 photos on Flickr that look exactly like this. So nothing special about that one. So why don't we get started? Let me bring up our deck here. So my name is Scott Stanfield. I'm the CEO of Vertigo. We were, like I said earlier, one of the companies involved in bringing you the Olympics. So how many of you watched the Winter Olympics on television? Now I expect to see a fair amount of hands. How many of you watched it on the internet? Okay, now, how many of you tried to watch it on the internet but were blocked by, yes, you know what I'm talking about. That's actually pretty good. Only like 6 of you were completely frustrated by NBC. We'll talk about that later. So I have with me here Bob Coward from Vertigo. He was our lead project manager and architect for the Olympics. Mike Moser would be here today. He was our other lead, but he is busy with a lot of the other similar partners on a little basketball tournament that starts Thursday morning. So that will be the next big live Silverlight broadcast. So it looks like a fair amount of you did visit NBCOlympics.com. We had a tremendous amount of support and good fortune on the project. Microsoft put a lot of effort and support behind these teams for the project. It was a tremendous success. There's virtually no problems for the live broadcast the whole time. If you were in the United States, you got to see all the hockey and all of the curling live, which constituted probably nearly half of all the competition hours. But there were 17 total events, and all of the events were filmed and were immediately available for what they call long-form replay. So as soon as the event's over, for the other events like ice skating or curling or biathlon, I went to women's aerials, which was just amazing, watching these women just fly down the hill and do those flips. All of that was also available online. Now, if you're in Canada, being either because it's the home country or just the agreement worked out with CTV, they had not only 3 channels dedicated over-the-air broadcasts, but their internet access was full on, everything was available, and it was using the same player. It was just the gray player. It was skinned a little bit differently. And also Norway. If you're in Norway, you got to see all the content as well. Now, and congratulations to Canada and all the, although we finished #1 in the medal count, but apparently outside of the U.S., they count number of gold medals. So Canada did finish with the most golds. So here's some other stats. I mean, these numbers, The number of video, this is big. 46 million total users, nearly 1 billion page views, over 3.5 million hours of video. It's one of those calculations that I think if you burned all that to DVD, it would stack to the moon or something like that. There was a photo experience that we'll talk a little bit about at the very end. I'll show you. That was equally big. It was very important to NBC, but they carried over 41,000 photos on their main site. That's a lot of photography. I personally have 23,000 digital photos in my collection that I've been accumulating for 20 or 30 years of my life. So to see 41,000 professional photos, and that's after all the bad ones have been vetted out, be part of NBCOlympics.com gave all of us another way to experience the content. So what I want to do first to establish some context, we were playing the player that Vertigo built while you guys were walking in. So I'm not going to go back and explore all the features. Instead, I'm going to run through some quick screenshots and give you a sense of kind of some of the areas that we're going to talk about. Now, keep in mind, I mean, at Vertigo alone, we have over, I think we calculated about 10,000 person hours on this project, roughly. It's about 5 person years. And that's just for Vertigo. Remember, there are about 14 partners involved in the delivery of this. So we can't possibly distill everything in 1 hour. There's so much to learn. I can't stress enough how important to us the content was and the honor to be involved in this. But it's just not possible to answer everything. But this is the last session of the day. We're going to have time for comments. We'll hang out if you've got more questions at the end. But right now what we want to do is tell you about the experience, how we got the most out of it, but more importantly, tell you why we made the decisions we did. It's easy to show what we did, but we have the ability to bring you the context of why we did it, why NBC wanted this, or why Microsoft wanted this, or why we did these features and packaged them the way we did, or made these configuration changes, because that's kind of the behind-the-scenes content that you can only really get today in a session like this. Some of it might show up in a white paper, but in general, this is the time to learn some of that kind of behind-the-scenes stuff. So, obviously, the number one feature period, if you look at just the usability in general, it's high-quality video with good audio at a good clip, good bandwidth. And that's the number one thing. Forget every other, all the other features I'm going to show you. If you don't have this down, you don't have anything. And if you have just this, you're halfway there. If you just have a moving rectangle that looks as good as television, if not better, and it's not completely painful to get to, you're halfway there. Of course, you need to make sure that NBC, who spent a lot of money on this, and this is all public information, they spent over $2 billion to license the three sports for Beijing, Vancouver, and London. They spent a lot of money, and for some reason they announced that they were going to lose money before the Olympics started, which is kind of a downer. But the advertising market was a bit soft, but they have to recoup this investment. And like it or not, we have to, the way they recoup their investment is through advertising. So a lot of the experience, you'll have ads at the top, ads on the side. It's just the way the world works, and we all know this right now. But it's important that the experience is flowing and smooth, because if you're hit with too many ads, you're going to be discouraged and you won't come back and watch the content. So from the user experience perspective and the team at Vertigo, we're always just kind of a give and take. Like, we're trying to balance what's the right way to deliver the advertising, because that's how it's monetized, but still ensure a good quality experience. But without good video, you're not going to get there. One of the big innovations for Silverlight Smooth Streaming for this event, and we did test it earlier in Sunday Night Football, is what came to be known as the trick play. It's a collection of features around the DVR experience. How many of you have a TiVo or similar DVR at home? So you get the idea. You can pause it, you can randomly seek, you can fast forward. But this is a big deal. It's live, and the fact this works with live is pretty cool. But there's no buffering. So you can randomly seek anywhere in the stream and jump directly to that spot in time, and you're not waiting for the buffering 20%, 30, 70, 100, and then go. It's immediate access. And it will pull down a stream that's appropriate to get you started right away and hopefully ramp up very quickly. So we gave people to fast forward at 4x and 8x. You can skip back in time by 10 or 15 seconds, which is really useful. If you see something you like, you can back up, and you can also put it in slow motion. So this was a very, very popular feature, and we got a lot of really good feedback. And also, it gives us a spot to do some nice animation. It turned out that little window in the upper left-hand corner became somewhat of an identifiable branding element of the player. So we see that show up again on the Norwegian player and CTV, among others. So we obviously have a video track, and we have an audio track to go with it. But we're able to get play-by-play and key events as a data track in the manifest itself. And Bob's going to go into detail how this works later. But as the video is playing, we have all this other articulation, this data, not only about when to serve an ad, but also details about every single play. So you have that as a marker to jump to a different spot in the action. We created several players, I think 7. What was the final count?
7, I think 7 different modes.
Yeah, we had all these different little players. This is an example of a mini player. This is before the Olympics started, but this is an embeddable player. So NBC permitted a certain amount of content, not live and not long form, but small highlight clips to be embedded on people's blogs or press sites, etc. That's a scaled down set of the features. We also have a whole selection around advanced advertising. So in order to really make this work, NBC required us to go through an IAB, it's the advertising board, I think, Internet Advertising. I just know IAB. Anyway, it has to be an IAB certified solution because that's how they verify or validate that when they serve an ad, that they can truly get paid for it. Now, we know when we were being requested to serve an ad, but we couldn't go get it. We had to pass it off to a DLL that was blessed. And this is it's Google. It was the DLL, right? From Dart?
DoubleClick, yeah.
Yeah, so Google purchased DoubleClick, and that's the Dart engine. So we had to work with them, say, is this code good? Because we're going to tell you to go play an ad, and then you go verify that we played it, so NBC gets the revenue recognition. Now, this is where it starts to get really crazy, because when you're live and you have advertising that's being brought in over the internet, how do you handle the DVR experience? So if you back up over an ad or fast forward over a potential ad break, there's a lot of basically what comes down to business logic and requirements from NBC that says we feel like these are the right parameters in which we would or would not serve an ad. So for example, if you saw an ad in the last 20 seconds, or 2 minutes, 120, and you're skipping around, you're clear. You're not going to get another ad served while you're moving around the stream. We had 6 different ad templates labeled A through F. So if there's a quick break in the action, like an icing call, maybe we'll throw in a quick 15-second ad, so A template. Or if there's a long break, like between periods, they'll roll a couple of F templates. And also along the way, it was very valuable for NBC to create these high-level sponsorships. So the player itself could be taken over, or the outer Chrome and HTML could be branded or customized for, say, Coca-Cola or DirecTV, so they have their own like mini channel. And we think this is an area that you can't do with the TV, really. Like TV, you can't brand the television set itself, but you can on the web. So we think this is another way that, as broadcasters try to find ways to monetize live content, this is a very powerful way for them to do that. In the full screen mode, we have this Video Content Explorer. So we gave people an alternative way to find related and connected videos either by athlete or by country or by event. Because, like I said, there were millions of hours of content. So we had to find a way in which to stitch all this together. And this was a feature that's kind of always there in the background, available for people to go navigate for other content. There's a Twitter feed, right? You can't do anything today without a Twitter feed. So yes, we have a Twitter feed. That's a really old screenshot. I think the torch is still being run at this point. So that's an overview of the features. So you're getting a sense of there's advertising, there's some trick play, there's data integration. One thing to keep in mind is that what we showed in the previous session, just to get a smooth streaming player on the screen, if you could charge $1 million per advertisement, per view, like Chris, if you went to the site and you watched an ad and NBC could charge somebody $1 million, you don't need a CDN. So you only need about 100 of those and you're good to go. So the reason we need CDN is to pay for it to get the scale for the advertising. So advertising and the monetization of this content and the use of a CDN go together, as well as a lot of the logic behind the scenes. So Bob will talk about features around the health monitoring of the system. Of course, we want the system to work well, but we have to verify that everything's smooth and running to NBC's business rules. So there's a lot of that behind the scenes, but at the same time, we're trying to balance the user experience to give them something engaging and fun to look at. So at this point, I'm going to turn it over to Bob, and he's going to take you behind the scenes and talk about a lot of these features. Bob?
Thanks, Scott.
And apparently, you still have 59 minutes and 53 seconds. No, we have 45 minutes. Cool.
Okay. All right, so we've seen a quick overview of, well, what's there. Now, how does it work? So, at a base level, if we want to get video playing in a video player, how is that going to happen? So we're using smooth streaming technology, and just as a quick 2-minute overview, Smooth streaming is based on FMP4s or fragmented MP4s. And the way that that works is you have MP4 video files, which are actually a single contiguous video file per bitrate. And it's going to be virtually fragmented by a manifest file. So as an example, let's take a look here. Now, this is a trailer for the movie Public Enemies that has been encoded for smooth streaming. And the first thing you'll notice is we have these ISMV files. So each of these is a single MP4 file, and this is not fragmented. So if I wanted to watch, say, the 660 bitrate here, I can just open this up in Windows Media Player, and it will play, because it's just a normal contiguous MP4 file. Okay. So what else do we have going on here? You'll also notice that we have this ISM file. And what this is it's actually a server manifest file. And that's going to describe the relationship between the media tracks, the bit rates, and the files on disk. And this is only going to be used by IAS Smooth Server, so Smooth Streaming Server. It's not going to be used by the client. There's no references by the client to this. The ISMC is what the client is going to reference. And the information that this file has are the codecs that are used, the available streams, the bit rates that are encoded, and the resolutions, the markers, everything that you would expect to see in a manifest file. So let's crack open a manifest and see what one of these will actually look like. So this is a manifest file for one of the Olympic videos that we had. Is that helping? Cool. Okay. So what you'll notice first is that basically we have these 4 stream index elements. And the important ones here are video and audio. So if we expand out the video node, you'll see that for each of the bit rates, we have something that describes what is the bit rate, what is the encoding, and the height and width. And then what you'll see down here are the references to each of these 2-second chunks. So this is where the actual fragmentation occurs. And this is where each little 2-second piece is referenced. So the big concept here is that this manifest file is just a big reference to existing video file that's out there. You'll also notice that in addition to the video and audio, there's some text tracks for advertisements and play-by-play. So I'll get back to that in just a moment. So let's talk about what those are. And the idea behind this is that it's in-stream data. So rather than going out and, say, writing a polling service that pulls an XML file to give me the information that I need, so if I have a Twitter feed or if I have important data that's coming in, if I have play-by-play information, instead of going out and polling for that in my application, natively right within the stream, I'm going to stream in the data and the advertising information. So we have markers that play just like video. Now, Mio from iStreamPlanet is going to do a demonstration a little bit later to show you how you actually get an advertisement inserted. And the basics of it are that we have a live feed and a delayed feed. The live feed is watched by someone who is an ad operator who says, okay, well, here's a break in the action. I'd like to insert an ad. And then the player itself is going to watch the delayed feed so that there's enough time for a human being to actually interact with this, insert an ad, and have that get up into this delayed feed. So switching back to the manifest here, you'll notice that in this ad op node, we just have a bunch of these base 64 encoded strings. So let's take a quick look at what all this gobbledygook means. So let's pull open a base 64 decoder. And take a look at what's in here. And when we decode this, what you'll notice is that there's something called an in-stream envelope. So this is the wrapper that all of the in-stream data comes in with. And then within here, you'll notice that the type of data that this is it's an ad opportunity. And specified here is the time at which the ad should play and a template type. So as Scott alluded to previously, we have different templates that can specify either a 15-second ad or a big ad pod. But right now, this is all I need to know for my player to be able to say, okay, at this time, this is the type of ad opportunity that I'm going to play. It passes the information on to the Dart DLL, and that then decides, okay, well, these are the ads that I'm going to play. But that's really all you need to do, is to pass that information along. Another really exciting feature is live to VOD transitions. So, typically if you think about once I'm done watching a live feed, what happens next? Well, at some point I'd like to go back and I'd like to check out, well, what just happened? I'd like to see a VOD of what I just watched, and ideally I'd like to see some highlights. If it was an exciting hockey game, I'd like to know, well, what were the big goals? I'd like to go back and see those. So the way that this works is we actually have all of these MP4 files out on the IIS origin server, and none of that changes. Once a live event is done streaming, they're just sitting there and they're ready. So the way that live to VOD transitions work is that it sort of creates an instant VOD as soon as the live event is over. The player automatically becomes a VOD player. So the stream stops, and there's a little isLive attribute on the root node of the manifest, and that's just going to flip over to say, hey, I'm false now. And that gives the player the information it needs to say, well, let's flip over into VOD mode, let's hide our go live button. And the live manifest is just copied over, and it's just copying a simple XML file saying, okay, this is the VOD manifest now. And at that point, we have the CDN, and we use Akamai for our CDN. So, if you still have a reference to this live file and you hit the live file, you're just going to get an HTTP 302 redirect sending you to this new VOD manifest file. And this VOD manifest is just referencing the same MP4 files that were there. So no data needs to be copied over. There's no post-processing that needs to occur. So you've got an instant VOD as soon as you're done. And you've also got instant highlight creation. So let's talk about how highlight creation worked for the Olympics. Now, if any of you saw Jason's session, Jason Seuss, he did a whole session earlier today about the rough cut editor. So this was a tool, and it's going to be released at some point in open source, that can be used to create highlights. Now, again, the way that this is going to work is it's going to create a reference file. It's a composite manifest file. It's similar to the manifest that we showed earlier. But really, all it's doing is referencing pre-existing video files. So one of the things that you can actually do is if you're watching a hockey game and a big goal happens, you can be cutting a highlight clip for an event before that event has actually finished happening in real life. So if you think about the way that highlights are usually created, for a live event, you'll have the live event end, you'll then have some video, you'll then sit down with the video, you'll make your cuts, you'll have a new file that you then upload to a server, and that's your highlight. With this, though, almost as soon as this is done, you can do a mark in and a mark out, and you've got your highlight via a composite manifest file. So let's dig into this and see what an example would look like. So here we've got an example of a CSM, and this looks pretty familiar. It looks just like this manifest that we saw previously. So you'll notice we've got these clip elements here. So what do we have in a clip? We've got the URL of the original video file. And that's just going to, when the player actually loads this CSM file, it's going to make a head request to the original video. It's going to say, hey, is this original piece of video still there? And that's all it needs to do. You'll then see that there's a clip begin and a clip end. So there's something at the beginning and something at the end. It's just a marker saying here's where it starts and here's where it ends. And then just like a normal manifest, it's going to have all of the bitrate information and all of the references to the video chunks. So let's take a quick look at this URL and see what it looks like. So we've got a little demo player here that I can show you. Sure.
That sounded pretty good. While Bob's bringing this, I want to add something. There's a reason why the highlights are important. I mean, you think of highlights like what you see on TV or ESPN, but one of the reasons why the highlights are so important for the Olympics is because they weren't subjected to the same broadcast, same restrictions. So in other words, if you were in the U.S., you could view NBC Olympics, and you could view as many highlights as you want, but you could only view the live hockey games and the live curling matches if you authenticated as a cable or satellite subscriber. And it has to do with just the relationship that NBC has with their partners, and they have to honor that. So, but the ability to create highlights very quickly still allowed NBC to reach a broad audience. Well, this seems like kind of a cool ESPN-style feature. It's a very important concept for the monetization of the event, and the fact that you can do it instantly. That's a huge deal. You don't have to have banks of people trying to do transcoding and Final Cut Pro cutting out highlights. As long as you're happy with jump cuts between the sections of the video, you can get these like before the hockey game's over, you can already have a highlight of every goal scored, ready to go.
Thanks, Scott. So as you can see, this video is just kind of jumping around. It's playing perfectly well right now, but it's actually just some testing that's being done. If I skip forward, you'll notice that there's actually some real content here. So what this CSM file does, you'll notice this is a 23:14 long video. Get some hockey players fighting there. That's fun. So I'm looking at this CSM file. So let me copy the URL of the CSM file that we were looking at. I've got it in another tab here. And let's view that. So you'll notice what I did just as an example is I said, well, I want 2 clips. So I actually have this edited together highlight, and I just made 2 copies of it. So I've got 2 copies of the same clip. So this is actually a 7-minute and 30-second little highlight that was made with this CSM. So what happens when we put 2 clips together? And you'll see that actually the player will seamlessly be able to recognize this as a single highlight file. So when we load it in here, you'll notice that the total time is 15 minutes. So this is taking 2 7-minute and 30-second files and just appending them on to each other. So as you can see, this is just a compilation of the best goals from this game. So let's skip ahead to right before this transition point. So here's the last 10 seconds of the first highlight. And
hey, Bob, can we leave that pause there for a second? Can you
sure.
back up? Just back up. I just want to see that moment again. Skip back. Leave it on the score. And we'll just leave it there as if the other game never happened. That was an awesome matchup.
This was a pretty exciting game. So as this ticks down to just the last couple of seconds of this clip, you'll notice it just starts on the next item. So it's totally seamless. And again, it's all being done by reference. So this is just the beginning of this clip again. So it really gives you a lot of flexibility. And these are a couple of screenshots of the rough cut editor. I'll probably just breeze through these here since you can get a lot more detail on this from Jason's deck from his session. So another important thing to figure out here is, how is this going to work if something goes wrong? Because something's going to go wrong. It's a huge event. It's a long event. It's got a ton of traffic. And at some point, something unexpected is going to happen. So a couple of things. First of all, as we mentioned, we have this Silverlight Media Framework. And underneath the Silverlight Media Framework is a component built by the IAS client platform group called the Smooth Streaming Media Element. And that's the basic player. So if you have a couple of 404s on some chunks, it's on the internet. Occasionally there will be issues. The player is actually resilient to that happening. It's going to continue. That's how smooth streaming works at a base level. It will roll with the punches, and it will keep playing your video, even if you've got a few occasional errors in the delivery that happen. However, if you have 50 consecutive chunks error, something is probably wrong, and you're probably not going to be able to recover. And at that point, the smooth streaming media element is going to say, OK, media error, something's going on. Now, at that point, what the Silverlight Media Framework is going to do is it's going to say, OK, let's try again. Let's at least try to reconnect to this feed and see if that works. So it will make 4 reconnection attempts. And that's what this first screenshot is here. Now, beyond that, if those 4 attempts fail, we're in what we call a stream failure rather than just a media failure situation, where we're saying, you know what, according to our logic, something's definitely very wrong, and we don't think it's recoverable. So at this point, what we're going to do is we're just going to display some alternate content to the users to say, listen, there's a lot of great video content here. Go look at something else. There's a problem with this video, but let's keep people engaged. Let's try and keep dwell times up, and let's keep people in this site. So the bottom one is actually something that's custom to the Olympic site, and you can basically handle it on your site however you'd like to. So let's take a quick look at what this situation looks like. So I've got my video up here, and I want to start causing some trouble. So there are a few ways I could do that. I could just pull out my LAN cord here. But that's not exactly a great way to simulate what happens when you have a failure, because if there's a failure in the video delivery, that's not necessarily the same thing as a complete loss of internet connectivity at the client. So really it's important to try and simulate what is really going to happen in these failure situations as surgically as possible. So what I've got going on now is I'm just opening up Fiddler, and I'm doing an auto response off to a 404. So all of these video chunks that we're seeing come across are the various players that I have open. So it's basically saying for every video chunk, I'm actually going to redirect that to a 404 response. And so you're seeing the video is not playing now because of that.
That's cool.
So let me just bring Fiddler back up here to see what's going on. It actually looks like Fiddler is not responsive.
There we go.
So that took a little bit longer than it usually does, but you'll see that this is actually recovering now, and it's saying, okay, let's try and do this automatic retry. So because Fiddler is unresponsive for some reason, I'm just going to kill it. So now that Fiddler's out of the picture and we don't have this thing causing problems anymore, we're to the situation now that, you know what, the video is available again. And this is the type of situation that can often happen, that the video comes back up, it seems to be working again. So we're back to video.
Nice.
We've managed to recover from this failure. And that's what we want to have happen. We want to have a media failure and not a stream failure. I cut off my own applause line there.
That was good, Bob. Thank you.
And it's important to note that, once again, this is part of the open source Silverlight media framework. So this is something you get for free there. And it's really the, advanced scenarios that you want to customize to your particular experience. All right, so let's talk about the CDN. This is obviously a very important piece of the picture. So, without a CDN, you don't have any way for this massive amount of load, this massive amount of traffic to be properly handled. So, at a very basic level, the CDN has a bunch of edge servers. And instead of hitting just one server for this content, there are thousands and thousands of servers that are properly configured, set up in geographically appropriate locations that handle all of the traffic that's coming out. And those edge servers are pointed to our IAS origin servers. That's sort of an oversimplification, but that's the basic way that it works. So a couple of tips and tricks here. So one of the big things you have to do when you're configuring your CDN is you have to look at your time to live values. So for example, let's think about, we have video streams that are out there, and those are fairly straightforward. You know how long you want those to live. But we also have player assets that are hosted up on the CDN because there are just a ton of people that are coming and downloading these players. We have our players then making a lot of calls out, say, for a Twitter file, for example. Now, a Twitter file, I'm probably going to want to hit once about every 30 seconds to make sure that I'm getting a good amount of updates. So I'm going to have to balance that to say, listen, the edge server is going to cache that Twitter file. And I have to think about how long I want the edge server to cache that before it goes and hits the origin server to get a new copy. If it's too long, I'm not going to get updated Twitter information in my player. But if it's too short, then I may be sending too much load to the origin. So that's something to think about. The other thing you need to consider is cache busting. So in this Twitter example, I've got a Twitter file, and Internet Explorer may say, hey, I'm going to hang on to this file for you and keep giving you the same version. Well, I want my Twitter to update, so that's really bad. So what we do is we tack a query string parameter onto the end of our request for this Twitter file, for example, and that's going to bust through the browser side and the the proxy side cache. So that's great. Now I don't have my proxy or my browser caching for me, and I'm busting through that. I'm always getting the latest version of my Twitter file. Great. There is a problem here, though. which is that by doing that, you're also going to bust through the CDN's edge server cache of that content. So instead of the edge server keeping a nice, clean, every 30-second copy of this, it's going to say, I do not have a good copy of this because there's this query string parameter, and I'm going to go hit the origin server. Now, imagine that you have 500,000 requests every 30 seconds coming in from players going to these edge servers, and they all go back to the origin server saying, hey, I need that file. That's a big problem. You need to make sure that that doesn't happen. So we've actually been burned by this in the past. A little story, I was in Denver in a very small area in the Nuggets practice court. And this was at the Pepsi Center for the Democratic National Convention. We were streaming that out for a few days. And everything seemed to be working fine. We were monitoring what was going on. And then Hillary Clinton got up to speak. And I think this was on day 2. And this was the first huge spike in traffic that we saw. It was the first big spike in peak concurrent views that we saw for the convention. And as that was happening, and as Hillary was speaking, we all of a sudden started to get reports coming back that, hey, people can't open new players. They can't see Hillary speaking. Anyone who launches a new browser, launches the player, cannot see Hillary speaking. So we said, okay, well, that's interesting. Let's go check that out. We logged into our origin server via remote desktop, and nothing was responding. So the entire origin servers were completely locked up. And basically what was happening is instead of helping us distribute the load, the content distribution network had turned evil, and it was becoming a denial of service attack on our origin. So we managed to get the problem resolved pretty quickly, but it is something you have to watch out for.
Good thing we learned from that one.
So
we thought it was the Republican National Convention.
So real quickly, security and URL protection. Basically, Akamai was able to issue 403s for us if there wasn't the proper authentication. And geo-blocking. There's also a lot of content coming through from Canada. You don't want Canadian users to be able to hit NBC's content because the IOC sells the rights to each broadcaster for a specific country. So let's get into logging and real-time health monitoring. So we've got this massive, massive event going on, and we're sitting in a war room. What's happening? I've got my player up and it's playing video. Well, what does that mean? What does that mean? It may mean that I have a good connection here and that things are fine, but I'm missing a lot of information unless I do a lot of logging. So in the Olympics, we set out to have a very, very high level of confidence that we know what's going on with the entire base of players as it's happening. So one of the tools that helped us do that was Conviva. And this is a tool, you have a couple of graphs that you're seeing there from Conviva. It provides us with real-time health monitoring. So a typical example is that we can take a look at the buffering ratio average for all of the players that are out there. And if we're seeing it hover just under 1%, we know that we're in good shape. If we see a big spike going out, we know that there's a problem. If we see that there's a specific clip, a specific highlight clip, that we're seeing a large, much larger than average number of errors occur on, we know that there may actually be an encoding issue, and we should take a look at that. The big deal here is that instead of being reactive, instead of waiting back, letting your users tell you, hey, there's a problem, you can be proactive and actually say, all right, I'm looking at what's happening. I know who's watching my feeds. Another story is you can actually get a player ID. Let me pull up our player. This is a specific player ID to this machine, and it's stored in isolated storage. So one of my colleagues, Mike, was on an airplane, and he was on Virgin, so he had internet on the plane. He was trying to watch the Olympics while he was flying, and he was getting something horrible, like 0.07 megabits per second. But he was trying to watch the feed, and he sent me an IM, and he said, hey, it's not working too well. So I opened up Conviva. I was able to put in his player ID and see his specific buffering information, all of the information about the health of his player, and of course I saw, well, you've got horrible buffering going on, and you have a completely inappropriate internet connection to be watching this. But this is the level of detail that we can get to. So the CDN, Akamai, is also able to do some reporting for us. They can look at the tonnage, they can look at what's coming in, the egress numbers, so the video going out from the origin, coming into the CDN. They can monitor the health on their end to see what's going on. We also have a tool that we developed in partnership with Microsoft called the Smooth Streaming Health Monitor. So I'd like to do a quick demo of that here. And this is actually the link where you can get to the smooth streaming health monitor. So we've got some videos playing here. And what this allows us to do is it actually allows us to monitor health of a video on a machine. So this machine that I'm on now, and I'm actually going to zoom out a little bit here, is playing some video, but I may be seeing some issues with it, and I may be seeing some spikes. I may just see that the bit rate is lower than I would expect it to be, given that I've got a pretty decent connection here. So how do I figure out what's happening? And without getting into a lot of, pretty advanced debugging tools, if I'm just a user who's on the phone with tech support and, hey, here's my player, what's going on? This is a tool that we can actually fire up and just hit this connect to external player button. And as you can see now, it's actually detecting that, hey, I've got a video player. It's a Silverlight smooth streaming video player, and I'm going to start displaying all of the data about what's happening with its health. So this is CPU load right now. Because it is a healthy player, we're not having video or audio buffering, so you're not seeing that come up here. But this is just another tool in the arsenal of what you can use to figure out what's going on. If you have a particular user that's having issues, it's something that you can use to debug that problem. Hey, Mike, how am I doing on time?
You got 1 minute left.
1
Maybe
minute?
2. Yeah.
Okay.
We're getting Mio up.
All right, I'll start jamming through these. These are a couple of screenshots from Conviva, just showing the view of peak concurrent, which content is really popular right now. This is an important one: stream failures versus media failures. Like I was alluding to before, we want to make sure that we don't have a lot of stream failures, that all these reconnections are happening. So just to speak to the way that we at Vertigo work, when you're developing for a huge event like this, something that's going to be hit by a lot of people, but much more importantly, something that has a large number of partners involved, there's a certain way that we like to work. So a few things I wanted to hit on. Number one is we use the model view model pattern. And what that allows us to do is it allows us to work very quickly and allows our designers to work independently of the developers. So we have a separation of concerns within the code. Developers can be building view models while the designers work on views and blend. The other thing that we're really strict about is that we enforce blendability. So it's unacceptable to us if there's a view that you cannot load up in Blend. This is the basic way that we work. All of our designers work on these views through Blend. So if you're a developer and you do something in the code that breaks Blend, it's almost like you broke the build. You have to go fix that. And then finally, continuous integration. We like to make sure that we have a one-click deployment. We do obfuscation on our Zap, and we do versioning of the Zap and the JavaScript assets. So every time that we build, there's a new version attached. That means we never have to say, hit Control F5. We never have to say, clear your cache, and then the new version might be out there. We know what version is out there, and as you saw from that version view I pulled up before, we know right within the player what version is out. Finally, we archive all of the builds that are deployed so that if any issues occur, we can immediately roll back. And we expose our build environment to all of our partners. Now, that's a little bit scary, but we like to do it. And then that way, every time a developer makes a check-in right on our build server, everyone who's involved with the project can see what's going on. The more that you open up, the more comfortable people tend to get. So I had some comments on authentication and security, but I think we're probably going to have to skip by those. So you can get this deck, and you can just come talk to me afterwards if you have any questions about how we secured all of these streams. We had a couple of other lessons learned, and you can talk to me about those as well. So what I'd like to get to now is, the other big piece here is we've got all of this delivery. We've got, this player that we've been discussing now, but how did it all get up there? So I'd like to bring up Mio Babic, who is our partner with iStream Planet, and he's going to talk about that as well as show you guys how to do an insertion of these ads.
Well, you left me about, what, 2 minutes and 30 seconds?
No, you got 10.
Got 10? Okay, excellent. Yeah. So my name is Mio Babic, and I'm president and CEO of iStream Planet, and our company was responsible for a video workflow, which included everything from content acquisition all the way down to encoding, as well as the origin services. So today, quickly, we're going to cover the live ads insertion and play-by-play insertion demo, and then we're going to go to a back-end video workflow. Okay. Bob, you mind if I close this window?
the #1 center, again, going into the nation's capital. And he is proving his worth. He's got 6 goals, he's got 18 assists, he's got 24 points in his young NHL.
Because your fiddler killed my live stream. I'm going to have to restart this.
Well, everybody having fun here.
Oh, we have some poker action here.
Right now.
Excellent. Let's make sure we can enable the ads.
And Tom Hall will go out. So he's going to pick up the blinds. So the actor, Nicholas Gonzalez, taking down that pot with the all-in bet.
But we're trying to get some TV time.
Nick's got plenty of TV time. He doesn't need it.
Freddie a little distracted there.
I just want the money.
So what we have here on the right-hand side, we actually have a live video feed running off the origin, going through a CDN, which is Akamai in this case. And this is just a satellite feed that we're picking up actually off the Canadian television. And on the left-hand side, what we have our key events or play-by-play insertion player, as well as the live ads insertion player. So I'm going to go ahead and start it here. I'm going to enable the play-by-play. As you can see, we have a welcome to the session. I'm going to add another one. And Bob already talked about the concept of add text stream as well as the play-by-play text stream. So I'm not going to go into details of those. I will highlight though that our live stream is actually running 30 seconds behind our. Our delayed stream is running 30 seconds behind our live stream. So anything that I do on the left-hand side, it's going to show up approximately about 30 to 40 seconds on the right-hand side, which is our delayed feed. So you guys see now it says Mix Rocks because I've inserted that key play in there. Now I'm going to go ahead and launch a 50-second ad. And you can see here on the left-hand side, my timeline is saying 1:41, about 56. So once we get on the delayed publishing point, once we get to 1:41, about 46, we're going to see the ad. And it's a 50-second ad.
Can you afford to have doubts in your pregnancy test result? Introducing the new Clear Blue Digital with Conception Indicator. To give you double confirmation, it not only tells you if you're pregnant, but also how far along you are.
Clear Blue,
when doubt is not an option.
Here's our ad. So the idea again is the operator is looking at the live publishing point, and then we mute this. And then the audience gets that same action, being that a live ad, being that closed captions or play-by-play data or some key events data about 30 seconds later. And the concept behind 30 seconds is also adjustable. Inside the look ahead, inside the manifest file, you can modify that to any time slot that you want. So you guys thought that everything Bob showed you was really complex. Now, this is our entire video workflow architecture for the Olympics. Now, I can spend probably about the next 3 days trying to explain each one of these pieces here, so I'm going to try to simplify this. I'm going to the next slide. So essentially what we did is we carried 23 HD feeds all the way from Vancouver to the New York City to Las Vegas, our webcast operations center here in Las Vegas, Nevada. And then we ended up carrying 5 CTV feeds over the satellite and downlinking them all the way in Las Vegas, Nevada, for a total of 28 channels. Now, I'm going to take you guys back to some of our experiences during Sunday Night Football. During the Sunday Night Football, we ended up encoding 5 different feeds into a single manifest file. And I think we had, Bob, about 30 to 40 people on a call to do a single 3.5 hour event. So when we met with all the different partners back in Seattle, it was about October of 2009, we realized that doing about close to 1,000 events over 17 days will be virtually impossible to do this manually like we have done this in Sunday Night Football. And we had to do something completely differently. So we ended up writing this platform, what we call a video workflow automation platform, that enables us to actually acquire all the content, both CTV and NBC content, route all the proper video, create all the publishing points on origin, start all encoding processes, and then post the data back to the CMS system, Delta Trace EBO CMS system, basically saying, hey, I've started the video stream, go ahead, you can publish it to the website. So we went from Vancouver all the way to Las Vegas, all the way to the web in 60 seconds without any human intervention. Also on the origin side, this was another project that iStream Planet got involved along with Microsoft. We ended up building a fully redundant cloud-based origination services in 2 weeks. This included a total of 23 different servers, and primary servers, which included 3 what we call server pods. Now, each server pod included an ingest server, live server, delayed server, and a VOD server. And we had 3 pods across the primary origin, and we had 3 pods across the secondary origin. And the idea, again, is to make sure that we have a full redundancy across each value in our entire video workflow ecosystem. So let me move on to next. So in the summary, really, as a result of all this, we had 17 days where we streamed about 21 hours per day. We generated about 4,483 hours of content. That's a total of 834 live events. 25 concurrent live streams was our peak. At this particular moment, when we're pushing 25 concurrent live video feeds, we're actually creating and dropping on our origin 858 megabits per second. Now, to put things in perspective, about a year and a half ago, I think we had about 20 megabits connection in our office. And we would do a 10 concurrent webcast, and these are typical Windows Media or Flash webcasts, 500 to 750K, and we never even came close to exceeding our capacity. Now we have a triple fiber, dark fiber to our office, and 1 GB connection, 1 gigabits per second connection out of our webcast operations center. So it tells you a lot about how much the quality of video has grown, how much the actual requirements of creating this quality video have gone up. We have delivered everything with 100% success, and the entire process was done with 5 people. Now, to put things in perspective, during the Sunday Night Football, we had 30 people working on a single 3-hour experience. We have done, as you can see, 4,483 hours and 834 live events with 5 people. And we never had to do anything manually. Everything was fully automated. As a part of our video workflow automation service, they actually run the entire process of digitalization and publishing. It enabled us to schedule the content, to acquire content dynamically, do video routing, encoding, entire publishing points management, the live to VOD transition that Bob touched on a little bit, the failover, the resource management, and at the end of the day, it was completely driven by APIs out of the CMS system. So this is one of our days. I think this is 16, right, Bob? February 16, yes. So this is how one of our working days looked like. As you can see, all these different, the items in gray over there, those are the items that have ended, so live events that have ended. Items in green are actually the live events that are currently taking place. And the items in blue are the events that are coming up. So this is just a quick snapshot of one of our days. As you can see, running this thing manually without some kind of automation process would be quite a hectic process, as you can imagine. So with that, I will conclude and get it back to Scott.
Thanks, Mio. Thanks, man. Thank you. All right. So the last piece I want to talk to you guys about, which tends to get overlooked in a lot of the coverage in the press, but it's very important to NBC and to us, is the NBC Olympics photo experience. 2 years ago, I was here at MIX on stage in the keynote showing off work that we did for Hard Rock, the Hard Rock Memorabilia Project. And the next year, I showed off Rolling Stone. I didn't get to show off Playboy, but that's the one that launched that day, the Playboy Archive. Now, we've taken some of that same concepts and developed a photo experience here. And like I said earlier, there's over 40,000 photos on NBC Olympics, but this is done in Silverlight as well, and it's actually using smooth streaming. So I picked an odd one, awkward Olympic celebration. So this should be interesting. So I'll just let this play in the background. So now, although these are photos, it's still think about this for a second. So the fragmented MPEG-4 container that we use for smooth streaming, at the end of the day, we're just sending little small frames of images. Well, that's no different than this. So the Deep Zoom team was able to adapt their tiling technology to take it and distribute that same data over a fragmented MPEG-4, which means it's perfectly suitable for smooth streaming. It also means that when you take those 40,000 pictures and chop them up to all these little tiles, which is underneath the covers, that's how Deep Zoom is working, it generates a tremendous amount of residue. Lots of little tiny, tiny files, millions and millions of files. And Windows Server, I mean, when you have to manage over 10 million little files, I can tell you it takes 40 minutes just to delete a folder that has 1 million files in it. So you can imagine how cumbersome it would be to manage all this and propagate it. So we worked with Microsoft and we said we have to have this feature. We need to take Deep Zoom and the packaging technology and make it suitable for smooth streaming. And this was the experience that we got. So we have kind of this automatic slideshow, and we have a grid mode that you can go into, and you can use the mouse wheel to move around. Now, unfortunately, their back office system did not support the ability to, I think at the end of the day, we were limited to relatively small files. This system could have handled raw images of 100 megabytes. I mean, it's Deep Zoom. We've pumped through, I think, a gigabyte image on it before to zoom way in. But just given the sheer volume of photos that they had to process, they felt it was better to you have lots of smaller images. So you can zoom in a couple times before you start to see the limits of their photo quality. Let's see if I can find one more good one. Where's the Canadian still here? I'm not getting good marks from you, am I? I did have a wonderful time. You guys were very... Well, what was great is when Americans were competing, but Americans were competing and there were no Canadians competing, we always got an extra round of applause, which was always good. So you can see that, in addition to the video experience that we have, this is very important to NBC. It was also an opportunity to serve up more advertisements, like my favorite ad, the Red X ad. I don't know why that's happening. There's one other piece I want to show, that it's very important, actually legally obligated to show and keep the caption and the credits along with each photo. So if you see down here at the bottom, this was photos taken by Clive Mason. It's brought to us by Getty. But when we zoom back, there's too many images here to determine who should get the copyright notice. But as we zoom in, it pops up on the bottom. If I keep going in, it stays with it. And if I take this off, if I turn it off, it shows up at the bottom of the image. So it's always there. So that credit is still there at the bottom of each file. And if I zoom in, it sticks to the bottom of the screen. So a couple of small things that we felt like were important, but also relatively easy to do in Silverlight with all the advanced manipulation you have with XAML. Now, the final piece I want to leave you guys with before we break, and then what we'll do, we'll stop and we'll take some questions. There is an event I want to show you about. This is starting, what's today? So in about 36 hours, probably the largest live internet simultaneous viewership will happen Thursday morning. That's because it's tip-off for the first round of the NCAA March Madness tournament. And this is the project that we're currently... Did I do that wrong?
Is it CBS Sports, Scott?
Let's see. I should probably know the URL. There we go. Oh, NCAA. Let me launch the player. So it looks like, oh good, we have Silverlight installed. That's handy. And while that's coming up, we have to compare something. So for the Olympics, we have this boss button in the video. How many of you clicked on the boss button? Did you guys notice that? it's for some reason, it's like the Easter egg in all the video players now. It's also something that technically could be sold for monetization. It's essentially an ad that you're interacting with. Let me get a video spun back up, and I'm going to compare the boss button with March Madness because I thought it was pretty funny. And we have to wait for an ad to play. So, Bob, we can't show the boss button? We have to wait for an ad? What if your boss comes in now?
Then NBC will be making money and they'll be happy.
We got 20 more seconds. We'll tell you what, while that's going, let me go back to March Madness. And we're going, so now this is Flash. If you right-click on this thing, it's Flash. There's no booze? All right, so we didn't do that. You have to click HQ to watch in high quality. They're hedging their bets. You know, if they don't want to lose viewership, if somebody doesn't have Silverlight, to wait for them to, they might accidentally bail out. Not accidentally, they might not continue. But believe me, if you're a March Madness fan and the only way you could watch it online was if you had installed Silverlight, you're going to watch Silverlight. And it says it's connecting me to the action. I think what they're doing is connecting me to an ad because there is no action yet. But let me show you. Here's the Olympics boss button, which is just a spreadsheet.
Audiences loved it.
That's the other player going. 503, by the way, this is our Easter egg. That's our street address. That's all we could think of. So we're at 503 Canal Boulevard, so we made the time 503. And it got a little bit better in March Madness. Let me pause this. Yeah, I know. There wasn't even Windows 7, which I think the whole time we did it, we thought it
has been done for March Madness. I can confirm that.
It's really slow.
Maybe collision.
Did we still have Fiddler going? We might still have Fiddler going. So anyway, the new boss button. This is better. It's a memo. It says, why did you click the boss button now? It hasn't begun yet. Go fill out your bracket and come back later. And we still have 503, but now we've got Windows 7, which is good. And 2/1/2010. That's actually my company's anniversary, so that was just a little tidbit that's not well known. Anyway, tune in, and if you're still here in Vegas Thursday morning, it's going to be crazy at the sports books. Anyway, I want to thank you guys. I want to thank Mio from iStream Planet and our friends at Akamai to help us out with the bandwidth for this production. And I've had a lot of help from the TSG and Freeman, the other events people, to get the high-definition projector for this presentation, because this is about HD, with the camera and everything else. But anyway, thanks a lot, guys. Enjoy your last day at MIX, and we'll see you guys later.